So in this video, we're going to talk about a few methods to factoring third and fourth degree polynomials. So we've talked a lot about factoring quadratics, which are x squared. So third degree would be x to the third, fourth degree would be x to the fourth. So there's a couple different methods we're going to look at here. The first is going to be factoring out a greatest common factor, or GCF. That's nothing new. We've been doing greatest common factor factoring before, so a little bit of a review there. And then we're going to factor by unfoiling, which is setting up the two sets of parentheses and factoring that way. Once again, nothing new, but we're going to do this with fourth degrees, so it'll be a little bit different, but still very doable. And then the third is called factoring by grouping, and this is new. This is something we have not talked about yet, so we'll talk about that. So let's get into it. We're going to do two of each type. So here are the first two. We're factoring using a greatest common factor. So let's start with the first one. And what I notice that's in common with both of these is a 2 and an x squared. I can factor that out. So remember, this is basically undistributing. If I take a 2 and an x squared out, what I'm left with is x. And then if I take out a 2, I'm left with 4 divided by 2 is 2, and I took the x squared out, so these are going to be my two factors, 2x squared and x plus 2. And then I'm going to set each of those equal to 0. And then I'm going to solve. So divide by 2, I get x squared equals 0. And then I'm going to square root, and the square root of 0 is 0. Now, if you recall, we talked about if you have x squared, that means you have to have two answers. So really it's x equals 0 twice. I'll talk about what that means on the graph here in just a moment. With the other one, we're going to subtract 2, and we get x equals negative 2. So really we have two unique answers. One is 0 and one is negative 2. A lot of times if you have a 0 twice, that the same answer twice, that's called with multiplicity of 2. We're not going to get into all that vocab. So basically what we know is it crosses the x-axis at 0 and it crosses at negative 2. So here's what this graph looks like. Now a normal parabola would look like this. It would cross at negative 2 and 0, and that's what the answer would look like if it was x squared, but it's not. It's x to the third, and so it's not going to look like that. X to the third is going to look a little different. It's going to come up, it's going to hit 0, and then bounce right back up, and it's going to bounce right back up because it has those two answers that are at 0. So a third degree is kind of S-shaped, whereas a second degree, a quadratic or a parabola, is more U-shaped. So that's what this graph is going to look like. Every answer is going to cross the x-axis there, or if the answer happens twice like it does in this case, it's going to bounce off of it. Anyway, all right, let's look at the next one. So I noticed that each number is divisible by 3, so I can factor out a 3. And then in each term, I have an x, or an x squared, or an x to the third, so I can pull out an x. So that means I'm left with x squared minus x minus 6. And then I can actually factor what's remaining here. And I'm looking for numbers that multiply up to 6. So 1 and 6. 2 and 3, so that has to multiply to negative 6. That means I need to have one positive and one negative. And when I add them together, they have to add up to negative 1. So we're going to have x plus 2, x minus 3. And then we just set each of those equal to 0. 3x equals 0, x plus 2 equals 0, x minus 3 equals 0. And when I solve this one, I divide by 3, I get x equals 0. Here I subtract 2, I get x equals negative 2. And then on the last one, I add 3, and I get x equals 3. So this tells me that it crosses at 0, at -2, and at positive 3. So we're going to have an S shape that looks something like that, where it crosses at those 3 points. All right, so that is factoring using a greatest common factor. Mostly we're concerned about the answers, but it's also good to tie it into the graph. Okay, let's look at the next type, factoring by unfoiling. So these look kind of like the last one we just looked at, except instead it has an x to the 4th and an x squared term instead of an x squared and an x term. So the way we handle this is we set up some parentheses, and instead of x and x, we do x squared and x squared. And then we're looking at what are the factors of 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. I think I got all of them. And we're looking for which factors will multiply to positive 36 but add to negative 13. And that's going to be -4 and -9. And then you can just set each of these factors equal to 0. So x squared minus 4 equals 0, and x squared minus 9 equals 0. And I add 4 to both sides, I get x squared equals 4, I square root, and I get x equals 2 or -2. Same thing over here. I'm going to add 9 to both sides. I get x squared equals 9, square root, and I get x equals positive or -3. So on the graph, that means it's going to cross at, I'll do some tick marks here. Let's see, 1, 2, 3, 4. It crosses at 2, crosses at -2, it crosses at 3, and it crosses at -3. So we're going to have kind of a W shape here. It's going to go something like this, because it has to cross at those 4 places. And so that's what this graph would look like, just kind of the general shape. All right, and maybe I'll label it's at 2, at 3, at -2, and at -3. So let's look at the other example here. Same kind of idea. I'll switch up colors on this one. Let's do purple. So we have x squared times x squared will give me x to the 4th. And then I'm looking at what are the factors of 25. So 1 and 25, and 5 and 5. And there's only a couple options here. But I want these to multiply to positive 25 and add to -26. So that means we're going to have -1 and -25. And then I'm just going to set each of these factors equal to 0. I'll add 1 to both sides. I get x squared equals 1. Square root of 1 is 1 or -1. Same thing here. We're going to add 25 to both sides. We get x squared equals 25. And then square root, and I get the square root of 25 is 5 or -5. So 1, 2, 3, 4, 5, 6. It crosses at 5 and 1, and it also crosses at -1 and -5. So once again, we're going to have kind of a W shape, and it's going to go through all 4 of those points. Whenever it's 4th degree, it's going to kind of look like a W. All right, so that is factoring by unfoiling. I don't know if there's a technical term for it. I'm sure there is, but hopefully you get what I mean by that. last thing for this video is factoring by grouping. So this is new, and I kind of wrote out the instructions over here in the rainbow pattern. And so it says the first thing to do is group the first two terms and the last two terms together. So you're really not changing this equation at all. You're just grouping the first terms and the last terms together, and we're going to separate that by a plus. So really all we're doing is we're taking a bunch of things added together. Some of it's adding a negative, but a bunch of things added together, and we're putting them in parentheses. So we're not really changing the equation because you can add things in whatever order you want. We just happen to write it in standard form. Okay, so group the first two terms and last two terms together. Check. Then what we're going to do is we're going to pull out a greatest common factor from each grouping. So in the first group, we're going to pull out an x squared. That's the greatest common factor. So we'd have left over x plus 2. And then in the next group, we have a minus 4x and a minus 8. So we're going to factor out a negative 4. And we're left with x plus 2. And it's important that you get the same thing in the parentheses once you factor out the greatest common factor, because that's what we're going to pull out next. So pull out a greatest common factor from each grouping. Done. And then it says each term should have a greatest common factor. Pull that out. And so we're going to pull out that x plus 2. And what's left over is x squared and minus 4. Okay, got that part done. And then it says set each part equal to 0 and solve. So we're going to do x plus 2 equals 0. And x squared minus 4 equals 0. I'll subtract 2 from both sides. I get x equals negative 2. And I'll add 4 to both sides. I get x squared equals 4. And then I square root both sides, and I get x equals plus or minus 2. So what's interesting here is negative 2 happened twice, and positive 2 happened only once. So let's look at the graph here. We've got negative 2 and positive 2, but since negative 2 happened twice, the graph's going to come up here and then bounce right off. And then it's going to swing back up and go right through positive 2, because positive 2 only showed up as one of the answers. Negative 2 showed up twice. That's why it bounces off. All right, so that is factoring by grouping. You follow these 4 steps every time, and assuming it is factorable, if this method works, then you would just follow these steps each time. Okay, so I've got a second example. We'll run through that. What I would encourage you to do is try this one on your own. See if you can do it without my help by pausing the video and then doing it yourself. But if you can't, that's fine. Okay, so let's go over this one together. I'm going to group the first 2 terms and then the last 2 terms and separate them with an addition symbol. And then I'm going to pull out a greatest common factor. And so for the first one, I'm going to pull out a 3, and I'm going to pull out an x squared. And what's left over is an x minus 9. And then for the other one, I'm going to pull out a negative 3. And I know I need a negative 3 because I want this to be a minus 9. So it's going to be x minus 9. And remember, like I said before, you want to make sure that these 2 factors are identical. If they're not, then you either factored out the wrong number or it's just not doable using this technique. Okay, now that what we can do is we can take out that x minus 9 and we write down what's left over. So 3x squared minus 3. And then we just set each of these equal to 0. So x minus 9 equals 0, and 3x squared minus 3 equals 0. We add 9 to both sides, we get x equals 9. We add 3 to both sides, I get 3x squared equals 3. Divide by 3, I get x squared equals 1. And then I square root, and I get plus or minus 1. So it's a third degree polynomial to start. We should have 3 answers, and indeed we do. And so it's going to cross at -1, +1, and at +9. So it's going to come up, swing down, go down a little more, and then swing back up. And that's going to be our graph. We just have to make sure the graph crosses those 3 points. Okay, so that is factoring third and fourth degree polynomials.